85% still didn't have the internet.
I didn't have internet.
And when I came here in '98, it just wasn't a big deal. And all of a sudden, of course, it swept America and the world. By 2005, it was 38%. Okay, so let's do we're going to do an exponential regression for how this has kind of come down and it kind of levels off. Now, wait a minute. I thought exponential was where it took off like a rocket ship. Like that. Or, instead of exponential growth, this is exponential decay, which is still exponential, right? So it's going to level off. And eventually you're going to get pretty close to almost everybody has the internet. It's going to level like that.
It's like taking the half.
Kind of, yes, exactly right. Half and then half and then half. Very good. Exactly. You see it on deeper level. Okay. Now, write an exponential regression for this data. Okay, so first of all, let's go to the first level there, which says clear. So how do we clear? All right, what do we do again to clear?
Enter.
Okay, but first,
Go up to L1.
press stat, and then edit, which is 1. Okay, so we can do stat 1. And then you highlight L1, etc. And then press
Clear, enter.
clear and enter, and then boom, it's gone.
I wonder if you did that at the same time if you do it.
No, probably not. Okay,
Debatable.
over here.
What happens if you delete your list 1 and 2?
If you delete it.
I think it's completely gone.
All right, you have to go back and read
Is it
it.
impossible?
Did you at the same time?
That actually works.
Oh, I just did it.
Is it even possible?
Yeah, if you hit the delete button, it'll delete it completely.
Delete, don't have, I didn't say delete, I said enter, clear. Not delete.
She left.
How do you get that?
Anyway, I didn't know that's possible, but anyways, okay, that's already up. All right,
No way.
so everybody go to the second row, which is graph. All right, so first we have to do what?
Graph.
Well, before we graph, we have to do what?
Insert numbers.
Enter all the numbers. Now, let's have a little discussion. Okay, 1990. What shall we enter?
0.
Okay, you could enter 1,990 and you would get an equation that works, but here's the problem. If you enter 1,990 for the first year and do all the years, you will get an equation whose coefficient is 1.7 times 10 to the 58th.
Awesome.
And that is massive, all right? So, we would be better off putting in 0 for 1990, something absurd, okay? And then what about for 1995?
5.
All right, how about 2000?
10.
Okay. And 2005? There you go. So it's all based off of 1990, right? Now, next column, which we plug in. Let's do 100 followed by 85, 60, and 30. Okay? All right, so right here, our reminder to ourselves is going to be enter numbers. Okay? And then, remember we want to graph it. Now, remember what happened last time? We tried to graph it, we couldn't see it. So just go straight to the zoom this time. Don't go straight to the graph. Go straight to zoom. And then what? 9. Okay? Zoom stat plot. And you want to monkey around with getting this empty screen again and going, wait, where is it again? Okay, just go straight to stat plot. Now, the graphing is actually optional. So when you do this on the test, or even on your homework, you don't have to graph it unless you want to see it. Okay? You can just go straight to the stat calc. Okay? And there it is. Now, that actually looks more linear than it looks exponential, doesn't it? So actually, a linear regression would probably be better for this one, but it says to do exponential, so you just go with the flow. Just do an exponential. Okay? And it will eventually level up. Okay, so let's do an exponential regression. So for the regression part, all right, let's put down some reminders for us here. We should go right back to the what button again?
Stat.
Stat. But this time it's going to be stat calc. Okay, stat calc. And we're going to do, which one is it? Looks like it's all the way down at 0, otherwise known as exponential regression. Okay? And if they tell you to do one, even if it doesn't look exponential, just go. Okay? And then it does absolutely nothing unless you hit enter twice. Okay? Go to cell, hit the back key. And there it is. Now, it's not an e to the x, though. It's a 0.93705 to the x. Is that still exponential? Sure. Any number to the x is exponential, right? Not just e's. Okay? E's just another number. So let's write it down. Every decimal place, 108.05030. 0.93705. Actually, drop on the 0.
Yeah, that's what.
Okay? To the x power. Anything I should put on this? Am I missing right now? Yeah. Let's protect the base in parentheses, shall we? Okay? Did you get those numbers?
Oh,
Just
Okay. All right, so that is your exponential equation right there. Now, here's the problem I have, though. I'm a little concerned. I'm very confused. Okay? Just say, hey, it's perfect because yours is right there. I'm very confused. I'm a little puzzle-wise because I look at this and I say, isn't this supposed to be an exponential decay?
It is.
And if it's coming in for a landing, shouldn't it be number to the negative x power when it comes in for a landing? Remember that? But it's not.
Less than 1.
If that base is less than 1, it will be exponential decay. Okay? So either you have a negative x power or this is less than 1. Right? Less than 1. In other words, if you do exponential, let's say we did that to the 5th power. If you take that to the 5th power, isn't that itself times itself 5 times? Wait, if you do 0.93, it'll be so much something.
Where'd you find this picture so I can include him?
Oh, weird. It stopped at like 20 minutes. Mine just.
Well, all right, anyway, so as we were saying, all right, anyway, if this base is less than 1, picture 0.94 roughly, times 94% of itself, times 94% of that, times 94% of that. Every time you multiply by itself again, you take another 94% of that, and you get smaller and smaller, right? Okay, so when that number is less than 1, this is declining. And if that number is bigger than 1, of course, it's just going to exponentially explode, right? Okay, there's the answer. Except for it's not. Yeah, it's not. There's your answer. Okay. All right, there we go. It's pretty easy stuff, right? Okay. Now, in this chapter, we're going to feature what the Weather Channel calls the 4 best weather cities in the world. We'll feature a different one on each of the homework, the notes. This is the third best weather in the world. This is the 3rd best weather in the world, according to the Weather Channel. Los Angeles, California. Well, we have to wait until the test and the sample test to discover that. We will find out.
That is actually really nice.
Okay. Oh,
What's
it's
the
a
best
good place to spend spring break. Too.
Except that it never gets
Oh,
very cold.
so
I like it like that.
It doesn't snow.
Okay. All right. All you have to do is go up to the mountains like 30 minutes from Los Angeles and there's tons of snow. Okay, so here is Los Angeles, California, and their average highs throughout the year. And it's so nice, as you can see, why 20 million people have decided to move out there. Okay, so will this be, do you think, a real-life linear regression, exponential, logarithmic, or sinusoidal? This is a very good real-life sine curve, isn't it? Sinusoidal, because the temperatures go up, they go down, they go up. Every city in the entire world has a sine curve, approximately, for its weather. There's even like the closest you can get to no change is probably Quito, Ecuador, which is right on the equator. And it just stays between 70 and 72 the entire year. So it's a very flat sine curve, but it still is a sine curve. It does go slightly up in the summer and slightly down in the winter. Okay, very slight. Even in Alaska, they go up, they go down. They're pretty dramatic. Okay, even there, they go up. Actually, but they're backwards.
Yeah.
So they go up in December and then they go down in June. So it's just reversed.
Is that everywhere south of the equator?
That's everywhere south of the equator. Exactly. Yep, it's all upside down. Very good. Okay, so like Australia. Well, it's April right now, but a few months from now, Australia will be freezing. All right. So let's do this. Let's go to the clear phase again. Okay, so quickly, how do we clear?
You really have to.
You just delete it.
Oh, I guess you can just type right over it if you want.
Yeah,
Couldn't you?
you can just type over it.
Sure, that's fine if you want to. Okay?
And what's the last one?
If you have OCD, I mean, if you like to be neat and tidy, then you can delete first.
Oh, you got it for
Okay, it's up to you. Clear plus enter. Okay, so just do the same process. And now we're going to enter all the goodies and see what happens here. All right. So everybody go to your stat here. We have all this cleared out. And when you enter January, how do you enter January?
Well,
Okay, just do 1, 2, 3, 4, 5 all the way down the page. That'll work. Evenly spaced. Kind of like a video game. How fast can you type it in?
Go.
Actually, I don't make a mistake. Okay,
I made a mistake.
Okay, type them all in, and then go back to the top again, and type in all of your temperatures. Okay. 68, 69, oh, what nice temperatures those are. Warm in the winter, moderate in the summer. No rain, ever.
For real?
Hence when my parents just retired there. It's paradise, my friends.
Your dad's not the dean anymore?
Not at UT.
Really?
43 years, and he said, I'm going back to Los Angeles where I came from. So my parents moved 2 months ago, 3 months ago.
Oh,
There's
God.
no rain ever out there.
My brother used that too.
That's why we went out to Los Angeles, Los Angeles for spring break. See the parents' new man?
That's your great.
Man shack.
Man shot.
Mansion. Yes.
My son taught me how to do it.
See the parents are very small. Okay, all right, so we got this. Now, let's go to something else. Oh yes, this right here. Enter numbers. Then we go straight to, I'm gonna break something in a second. My record for not sending anybody to the office for the last 6 months. All right.
That's 6 months ago?
Yes, 6 months ago. All right. Hit Zoom, all right, and then hit what? 9. Ooh, look at this. Anybody see it? That's a very nice sine curve there, isn't it? Okay.
Not really.
Yeah, it's a little curvy the other way at first. It should be concave down, it's concave up. Yeah, yeah. It's a little weird, but you can approximate it with a sinusoidal regression very nicely.
You didn't do it?
All right, so how do we do this? All right, let's go back to the magic button that we all refer to as
Allah.
What? Stat. Off topic. All right, stat, calc,
Logistics. Sign reg.
and yes, there is a sine reg. I'm actually, you know what? I'm not going to go down. I'm going to go up because you can go to the bottom of the list.
That's what I did.
Yes, indeed. Very nice. So everybody see where it says C, sinusoidal regression? Okay, we will choose that one. Mr. Wade didn't do anything.
Enter.
I'll hit enter again, and this one churns for a while. It's a little harder to do this one. Then it spits it out. So enter times 2. Okay, and you should have a final answer. Now you have to write down every decimal place because they want every one of them. All right. This is going to be the longest answer of any test question we've had the entire year, right? That's why I put a big long blank on it. So y equals 7.94399. Anybody get that? Okay. Sine of, by the way, what is that called again? If it sits out in front of a sine, cosine, or tangent? Sure, that's every function, but how about the amplitude? Yes, amplitude. There we go. Okay. So this is the amplitude.
Coach Wade, what if we're getting like 9 decimal places?
Oh, you probably didn't do float 5 if you did float 5.
I have it as 30.
Yeah, float 9 instead.
I got it going all the way up to 9.
You really don't have to go beyond 5. So I should have mentioned that, yeah.
Okay.
So